Hello everyone and welcome to the channel. We're diving into one of the most powerful tools in CATIA V5 today, the multi-section solid command. If you want to create complex shapes by blending different profiles, this is the lesson for you. Let's get started with the essential concept of the closing point.
I got this magic in my fingertips, designing dreams with every click. Shapes and wonders coming to life. With CATIA I cut through strife. In my mind the future's clear. No more doubts, no more fear. Crafting visions in 3D. CATIA's the key, don't you see? I can reach the sky so high. Build my dreams, no need to try. With every tool I sculpt my fate. CATIA helps me innovate. Every line precise and true. Colors bright and brand new.
Hello everyone. Today I want to talk about the multi-section solid tool. In previous lessons, you became familiar with the pad and rip tools. With the pad tool, you saw that we only had one profile. We could extend it in a straight direction. This direction was either one of the axes, a center line, or an edge of a 3D object. With the rip tool, you saw that we also had only one cross section. With this tool, we could extend our cross section along a curve. With the rip tool, we needed to draw a curve on a plane that wasn't parallel to the cross section. With the rip tool, the profile and the guide curve couldn't be parallel to each other. These two had to be created on two perpendicular planes or two angled planes relative to each other. In essence, with these two tools, we extended a single profile in a straight or curved direction. But what if we have two profiles that are on parallel or perpendicular planes? If we want to create a 3D shape by combining these two profiles, we use the multi-section tool. I will start with the simplest case. The simplest case is when the two shapes are identical. Imagine we have two circles with different diameters on two parallel planes. Note that these two circles were created in two different sketches. I'll emphasize that two circles in two different sketches. The first circle has a diameter of 30 mm and the second circle has a diameter of 50 mm. The second circle was created on a plane parallel to the XY plane. To create this plane, I used the plane tool in the Reference Elements toolbar. I'll use the Fill-In tool to adjust the zoom of the screen. I'll click on the multi-section solid command so it turns orange. Immediately, the multi-section solid definition window opens. This window has three parts. The top section, which is currently active. In this part, we select and introduce our sections in order. A note: we might have more than 2 sections. First, I'll click on the circle located on the XY plane. Second, I'll click on the upper circle. Now you can see that the names of the 2 sketches are written in the first part of the settings window. There are 5 columns in this section. In the first column, you see NO. This means the row number. So, the order of selection is important with this tool. The second column is named Section. In this column, you can see the names of sections that you have been selected. In the last column, you see the name Closing Point. The closing point is the starting point for creating points. What does this mean? When 2 sections are selected, the software first examines the 2 sections. Then it divides them into several parts, the number of divisions in such that the software can create the 3D shape in a suitable way. After the required number of points for each section is determined, the software starts creating imaginary points from the closing point in the direction of arrow shown on it. For example, 3 points for a circle and 4 points for a quadrilateral. Then it connects these points on the 2 profiles in order. This connection can be done in 4 different ways in the software. The default mode is Tangency then Curvature. Finally, it delivers a 3D object. Now pay attention to the 2 selected circles. On each circle, you see 2 words shown in red. First, pay attention to the word section. You can see a number in front of this word. This number shows the sketch plane on which that section was drawn. Second, you see the word closing point, on which the pointing arrow is visible. A very important thing you must always follow is that the direction of the arrows on the 2 sketches should be the same. I'll explain the reason for this later. In this current state and without changing other parameters, I'll click OK. You can see that the shape was created. Now, let's assume we have 2 rectangular sections on parallel planes. I'll click on the multi-section command again. First, I'll select the lower rectangle. Pay attention to its closing point and the direction of the arrow. I'll click on the second rectangle. I'll set the view from the top. Look, the closing points of both sections are at similar corners and the arrow directions are the same. I'll change the view mode to isometric. I'll click OK in the definition window. The shape is created. I'll press Ctrl+Z keys to go back. I'll click on the multi-section command. I'll select the lower rectangle and then the upper one. The closing point status is again the same in both sections. I'll move the mouse pointer over the arrow of the upper profile. After the pointer changes to a hand, I'll click. The direction of the arrow is reversed. I'll click OK in the definition window. You can see that the shape was created, but it also became twisted. I'll change the shape's display to wireframe mode. Look, the closing points, which are the starting points, are connected to each other. The second point on the lower rectangle is connected to the second point on the upper rectangle. The third point on the lower rectangle is connected to the third point on the upper rectangle. The fourth point on the lower rectangle is connected to the fourth point on the upper rectangle. If you pay close attention, the reason for the twist is that the same points are placed on the two rectangles in opposite direction. Now you understand why I said earlier that the direction of the arrows on the profiles should be the same. I'll press the keyboard shortcut Ctrl+C to go back to the first state. I'll activate the multi-section command again. First, in order, I'll select the lower rectangle and then the upper one. Now I want to move the closing point of the upper rectangle. Pay close attention. I will right click on the board and not the point. A menu opens. I'll click on the replace command. I'll move the mouse pointer towards the upper rectangle. The pointer turns into a hand. I'll click on one of the corners of the rectangle. The closing point is moved to this point. I want to change the direction of its arrow. I click on the OK button. I'll change the view mode to shading with edge. You can see that the shape became twisted again. I'll go back to wireframe mode. In this state, you can also see that the software has connected the points in order. But because of starting points were far apart, there was a twist. Okay, so far we've connected two completely identical sections. But what if our sections have different shapes? Suppose I want to connect a square to an octagon. In this case, the final shape changes from a square to an octagon. Now you can see the square and the octagon on the screen. I'll click on multi-section command. First, I'll select the square section and then the octagon. I'll correct the closing point and its direction on the octagon. To do this, I'll follow these steps. I'll right-click on the closing point. From the opened menu, I select the Replace command. I'll click on the appropriate point. To correct the direction of the arrow, I'll just click on it. I'll click on the OK button in the definition window. Now I'll face an error. This error is because of the wrong connection method. I'll explain. First, I'll click OK in the error window. In the second part, I'll click on the coupling tab. There is a box in front of the section coupling section. By default, the connection method is set to Tangency then Curvature. This mode is for when two sections are identical shapes. I mean similar and not the same size. When we want to make two dissimilar shapes 3D with this command, we must use the ratio mode. Of course, I'll show you with an example later that this isn't exactly true. Even two dissimilar shapes can be connected with the first method if the changes aren't too large. But what are these connection methods and what is the difference between them? These modes are different ways the software uses to find corresponding points of the two sections. After selecting this mode, I'll click on Preview. A preview of the shape is shown. I'll click OK in the definition window. I'll set the display mode to wireframe. I'll double-click on multi-section in the design tree. You can see the method of connecting the points in the shape. Note that 4 points are needed for the square and 8 points for the octagon. The software has considered the corresponding points of the octagon on the square using its own method. Now I want to change the connection method of the points in the two sections as I wish. First, by pressing the Ctrl+Z shortcut keys, I'll go back to the sketches. Then I click on the multi-section command. I'll select the square and then the octagon. I'll change the connection method to ratio. I'll set my view from the top. I'll right-click on the closing point of the octagon. I'll change its location using the Replace command. I'll set the view to isometric. I rotate the screen a little to get a better view. In the second part of the definition window, I'll click on the coupling tab. The coupling window opens. In the coupling window, we specify which points should correspond to each other. To do this, I'll click on the 3 dots inside the coupling box. A blue row is created in it. I'll connect each of the 4 corner points of the rectangle to 2 points of the octagon. I'll click OK. You can see the shape. Alright, this is enough for the first part of the explanation of this tool. Please watch the lesson twice. Practice with me the second time. Until the next session, goodbye.
Let's build the future. Come with me.